Cool. Thank you once again, everyone, for coming. Yeah, so my name's Ned Letcher. Some of you have been along to this meetup before, and many of you will be new. Um, this evening, I'm going to be talking about Python libraries for building data apps. So quickly, a little bit about me. I work as a data scientist at ThoughtWorks. So we help a range of organizations doing things with data, getting value from data. And I've been working in the data science area for a few years now. And over the time, I've had experiences, where being able to build out little interactive applications, and typically that involves data viz, so that's the connection to the meetup this evening, has incredible amounts of value. And it's a, whether you are using Python or other tools, but I'm particularly tonight talking about Python tools for helping you do this, and in particular, why it is a bit of a data superpower. So let's jump on in. So what are the kinds of things that are data apps? I'm calling it a very generic sort of this idea of an app or an application that's oriented around data. Well, let's have a look at some of these examples. And these are all examples that are built using the tools that I'm surveying today. So first of all, we have business intelligence dashboards. You can see here, this is made with Dash. It's for looking at data to do with New York oil and gas. So this is really highly curated information that's meant to sort of draw out key information. So you might, often these are key performance indicators or KPIs, and you can probably interact with this a bit. And there's a map there. There's some time series data. So that's one example. Another kind of data app are when we have tools for data exploration. So this is, this is, I guess, exploration and analysis, really. This is a visualization of bike journeys. I've forgotten actually where it's from, but a whole bunch of share bike data. And so this is a bit of data science that's been done to it. They've been clustered and with a clustering algorithm, and this interface is for exploring those clusters. This one comes from the category I'm sort of calling bespoke tools. So another app, another dashboard-like thing, but it's for generating color scales from an image. And we'll see that one in action a bit later. Now this one here, again, you could think of it like a custom tool for a specific thing, but this is so common that I've called it out as a separate category, custom machine learning tools. During machine learning projects, it's so common for people involved to need their own little interfaces, little GUIs, that being able to build out a quick little app is actually super valuable. So I guess the question that I want to put to you is, why should data teams make their own interfaces, their own data apps? One reason for this is agile prototyping. And the idea here is that we want to be able to, as we're building out the product, the model, whatever it is we're working towards, we want to get incremental feedback from users and stakeholders. So people who are going to be using this at the end, let's see how they feel about what you're building as you build it and get feedback. And then, if it's not sort of doing what it needs for them, they can you can course correct and you can pivot, rather than, there's the sort of the classic failure of the waterfall approach. We get to the end of the design, sort of this fully spec'd out thing, and it may not actually do what people want. So if you can build out like a prototype of what it might do, even if it's not the final version, that can help get feedback really rapidly. And then, as you saw before, we have tool building. So across data projects, there's a wide range of different tools that people might need, whether it's for collecting data, maybe for labeling images inside of, for image recognition, where you need data with, this is a dog, this is a cat, etc., things like that. And then the other thing I'd say is also, I'm calling this domain-oriented data ownership. The best people to sort of make the interfaces that you work with are really your team, the people working with the data. You know the data, you know the problem, and the challenge is if you have to sort of get a delivery team to come in, a front-end delivery team to build out a web app, they don't know the data as well as you, they don't know the problem, and also then maybe you may not be able to get them back in, especially if they're contractors or an external vendor. Maybe you're stuck with whatever the features were left in that project. So my sort of idea here is that web dev is a data superpower. And this comes from a tweet by Joel Gruss. unsolicited data science career advice, learn Flask and just enough React to be able to build functional front ends for your data science work, and just enough CSS to make it look not horrible. It's like having a superpower and it's not that hard. Now, I fully agree with Joel's point that this gives you a data superpower for all the reasons I just mentioned. And in some ways, it's not that hard to learn React. There's plenty of tutorials out there, but it does take a lot of effort and people have their jobs to do and their lives to get on with. So basically, I guess I'm sort of challenging that sort of, is that really realistic for a lot of people? For some, maybe. And so let's sort of unpack that idea a little bit more. If you're building out a data science project in Python, these are some of the tools that you could be using, your entire team could be working with. We could be doing some machine learning, some sort of web development stuff, databases, playing around on the cloud. Now I've thrown in all the kitchens, everything including the kitchen sink here, but this is not an impossible data library stack that you could be working with. Now, what happens if you suddenly need an interactive data app to prototype the product? It's like, well, do you spin up a modern web stack to do some web development? And then all of a sudden you've got this whole new sort of set of moving parts and dependencies to maintain. So that's not necessary, even if that is an option, even if you have those skills, it takes time and resources to do that. And for many people, it's just not an option. A lot of people will roll their own sort of solution. They know Flask, they know Matplotlib, and that can work, but it can sort of be a bit slow and you end up with a bit of a janky sort of solution. And I would say that sort of, maybe 5 years ago, that's sort of for, that would be what you'd do. But now this is sort of what we're talking about today. You have option 3, you can adopt a dedicated dashboarding library. And so really I'm saying, why sort of choose these sort of big data stack, modern web dev stack when you can have one Python library to add to your things on the left-hand side. The libraries we'll be looking at today are Voila, Dash, Panel, and Streamlit. They're all open source, and they've all got companies sort of behind them. So there's people maintaining it. There's a community as well as commercial companies sort of operating alongside. Now, when you're looking at Python libraries, one way I find helpful to sort of think about comprehending the Python visualization space for libraries is that we have our low-level libraries. We have Plotly, Bokeh, and say Matplotlib. These are really powerful libraries that can all do a lot of things, but they can be a bit painful to work with again and again, sort of very sort of like, can be a bit laborious. And so there are these higher level libraries. Plotly has Plotly Express, Bokeh has HoloViews, or with Matplotlib, you could be using Pandas and Seaborn. They're better ones to be working with abstractions over the top of. And I would recommend using these for your day-to-day usage, but you do sort of need to know what's going on under the hood in case you need to do fine tuning. But what we're looking at today is these ones that sit over the top. These are the interactive interface libraries that work with those ones below. And they don't all necessarily require you to use the ones directly below them. Some of them do, but a lot of them are quite flexible. So that's how I would sort of think about these levels of abstraction. What we're basically talking about with all these interfaces is reactive interfaces. You have like say a web page here or an interface. You've got a plot, you've got some drop downs. That's your layout. That's the layout that we're talking about. And then we have these callbacks, these Python functions that when given data or inputs, they return new data. And so what you see is that our inputs are wired up to parameters of the function. When you change the dropdown, it'll trigger a call on the server or maybe the machine you're sitting on. It'll return some new data and then pipe it back into the plot. And these libraries are all about making that process sort of convenient. So you don't have to handle the mechanics and the plumbing of that. And just briefly, this is sort of the timeline of some of these libraries. I guess my main point here is that, even though we had Shiny and R, which is sort of one of the, forerunners of these libraries, we can see a lot more of these libraries have been happening more recently. So this is a sort of a relatively recent trend. And just because I know that not everyone here is coming from a sort of a data science or Python background, we'll be talking a little bit about Jupyter Notebooks. These are just interactive development environments that allow you to interleave code and text cells. So you can see on the right, we've got some code, Python code, and then below that, there's the outputs of that code. So this is a common way for people to do data analysis. You can actually already create interactive interfaces with that. There's a tool called IPyWidgets, and they can wire up the functions to your plots. The problem with this is it's not very easy to share it, because you don't want to share an interface that allows someone to run arbitrary code essentially on your machine. That's a security problem. So that's kind of where things were at for a while, at least in the Python side of things. So now let's jump into these libraries and let's see how they can be used to sort of create your little data apps. So first of all, we have Voila. And the idea is that Voila will take one of your Jupyter notebooks that we just saw before, and it will turn it into a standalone web application. So whether that's a sort of a dashboard or a little tiny app for just sort of doing some stuff with data. And the idea here is that this enhances the process by which you're already doing research and analysis in a notebook, and then can then allow you to share the results of that analysis. Now, you don't have to use IPyWidgets, but that's probably the best candidate for you. And I think that was the idea behind Voila, in terms of the interaction, linking up your plots and your drop downs. So I'm going to quickly look at this demo. So you can see you run it on the command line. And so, yep. So this is the example of a plot that's been made in a Jupyter notebook. It's looking at different country indicators. Not too important really what the details are for this talk. Now, then we've run that notebook through Voila, and now you can see it's actually, there's a URL, localhost, but this could be running and be made available online for other people to share without the code cells to use. And so back to the slides. So yeah, so I've probably got a little bit too much content here, but I guess the idea is that Voila is using those IPyWidgets library for interactivity. It's using another library to convert the notebook into an HTML representation, and it's doing all the things you want to do, stripping out the code cells so people can't access your underlying computer. And you can run it with, there's two different servers that you can use. If there's a few sort of details there. But the really cool thing about Voila is that it works with all of the different Jupyter kernels, not just Python. So you know, R, Julia, and then there's actually tens of other different languages that it supports. And it has wide support for, say, Plotly, Matplotlib, Altair, Folium, and IPyWidgets, but no bokeh support if that's what you need. And as with all of these little web apps, a neat trick is using a library called ngrok, which sort of allows you to connect to something running on your local machine. Like you saw in my web browser localhost, I can actually connect that to a URL. So it's really useful for demoing a library live for, an application you've made live for a meeting, for example, that, you know, is on a Zoom call. Okay, moving on to Dash. Dash is basically, it's sort of allowing you to build out a bit more productionized web apps. And it works with Python, Julia, and R. And what we're doing is we're kind of essentially giving you an abstraction over the web API. So it's kind of like, you can sort of almost pretend as though you're writing a web app on top of HTML, CSS, and JavaScript, but you're not actually having to dive into the details of the web platform. So as you can see here, the demo is a little bit more involved. There's going to be a little bit more coding, but it's a lot less than if you are doing your, jumping into JavaScript and React. So this is an example of a Dash app that I've made to explore the Melbourne City pedestrian traffic data. So we can see here that we can look at, like, which are the most commonly used sort of sensors, commonly trafficked sensors in Melbourne. You can see, so this is actually for this year. So, you can see that obviously right around March, the traffic, drops precipitously. Then I was interested about this little spot here. It turns out June 6th, that was the Black Lives Matter protests in the city. So yeah, so this is obviously an interesting interface for exploring those insights. And I guess the interesting thing here is that, we can change it and look at, well, what was happening back in 2018. And any second now, it's running in debug mode a bit slower, but now you can see that, things are a little bit quieter. And we can even see like daily rhythms. And I think this is quite interesting. Oops, I've gone too far out. But if you sort of just go a little bit in, you can actually see this sort of like morning, lunch, evening peak as people travel around the CBD. So that's Dash. I do need to go quickly. Oh, right, yes. So the idea actually with Dash, a bit more to say, is that you're, this is the part that you write. You're writing Python code, and then it does the rest for you. It's actually using Flask to create an API that's communicating with a React app on the front end. So it's kind of giving you the power of creating front-end web apps using the modern web platform, but without having to dive into the details. So obviously you don't get as much power as if you were doing React yourself, but you're saved from having to write React. So it's quite a powerful tool. Again, I might have a bit too much information here. I've said some of these things. It's very horizontally scalable because it turns out your Dash apps are stateless, which means that all of the actions and the current state of the plots are only stored in the browser, in the client, not on the server, which means that you can have many worker processes, many different kind of containers or handling requests on the server. So that's what people refer to as being horizontally scalable. So and Dash is probably the best at that of these tools. I guess what I would say is if we look at the supported widget libraries, it primarily supports Plotly. So if you want bokeh, matplotlib, and matplotlib and Altair, you're a bit limited there. Plotly does do a lot though. So it really, a lot of the time what you need it will handle. And I guess what I would say is if you do need something else, you can actually create your own components for Dash because Dash components are just React components. So there's recipes for example, converting a D3 app that you've made yourself, and it doesn't have to be you, it could be someone else on your team, or maybe you get a contractor in, they'll build you out the components, and now your Python data analysts who know Python but not web development, now they're empowered with whatever that component was. So there's actually quite a powerful sort of extensibility there. And I would definitely recommend that if you're building out Dash apps, use the Plotly Express library, the slightly more abstract, more kind of concise wrapper around Plotly for building plots. And just recently, Julia was released, Julia, the programming language, as well as R and Python. Moving on to the third app, the third one is Panel. So if you remember back at the start, Panel is sort of based around the bokeh and HoloViews ecosystem. But you're not restricted to using those libraries. The interesting thing about Panel is it kind of gives you multiple modalities for building out your apps. So you might just build out your dashboard, your app within the Jupyter notebook itself and just leave it at that. And it's so you can sort of replace the IPy widgets for doing the interactive so it's like it can help you make your plots and exploratory data analysis for just yourself and your team members faster. Or you may want to deploy that notebook into a dashboard on the web. So kind of like Voila, that first app we saw. Or then number three, maybe you don't want to start with a notebook. You actually just want to start with a Python script. So kind of like Dash, and then deploy that as a web app. So it's very flexible in its modes of deployment. And I think that's the idea, is it's trying to meet people who have a very sort of heavy Jupyter-based workflow and offer a lot of flexibility. So the demo I have for this is the color dropper. This is a pretty cool, so if you want to create color scales, so you can see down below this picture, I'm adding more colors. I was meant to have this to the left. So basically it's like, you get the idea. We're dynamically creating our custom ramped color, so this is now code that we can copy into wherever we want to use that. So it's a really useful, so, this is just a very specific purpose that someone's needed this for. And so I'll just build a little interface. It doesn't have to be super polished, but it does what it needs to do. So yeah, so panel is built on Bokeh, like I mentioned before. Interestingly, it actually has 3 different ways that you can serve the dashboard or the app that you've made, using the Bokeh server, using Jupyter itself, or, and this is useful if you need IPy widget support. Uh, panel doesn't support that itself, but if you use Voila to do the serving, so what I mean to say is the Bokeh server doesn't support that itself, but you can use Voila to do the serving. And it has some nice abstractions for creating your layouts. So you've got row and column layouts, which is similar to what IPy widgets give you, but panel provides that itself. And then a neat thing is it actually has this funky offline mode where you can you sort of record all different permutations of the inputs to your dropdowns, and then it'll kind of generate each possible output state of the dashboard, and then zip it all up into a an offline HTML and JavaScript file containing that data. And so you can send around an HTML file without needing to deploy it on the web. That obviously only works for, I mean, it may not be obvious, but if you think about it for a bit, the problem is as soon as you have, 10 different drop downs or what have you, you have to have all the different commutations. So it's n by n sort of, the permutations start exploding, and that'll only work for small apps. Is otherwise your HTML file will be massive, and it won't be so great. Supported widget libraries, possibly one of the most flexible here. We can have Bokeh, Plotly, Altair, Matplotlib, and Sibon, Folium, deck.gl. And as I said before, if you do need to use IPy widgets, you have to use the Voila server. Okay, so finally, we have Streamlit, and this is one of the newest libraries that's actually shot to extreme sort of amounts of popularity, especially in the machine learning and data science world. And the idea here is that this is sort of really that custom bespoke tooling. If you're running a machine learning project, you're just going to continually need to sort of build out these tiny little apps that help you do things. And it's going to be easier if you have an interface for doing that. And the key thing about Streamlit is it does it in a way that is going to be familiar to people who already are familiar with using Python writing scripts, as opposed to more of a sort of a web development way of thinking about the layout of your page. So I've got a quick little demo here. Right, so this is looking at the Spacey natural language processing tool. You can see that it's analyzed this sentence. Mark Zuckerberg is the CEO of Facebook. It's given you a syntactic analysis of the sentence, including its parts of speech, like determiner, noun, adjective, and then also the named entities in this sentence. So Mark Zuckerberg is a person, Facebook is an organization. That's a sort of a tagging challenge in machine learning. And so we can do things like say, Mark Zuckerberg is the CEO of Facebook and the internet. And you'll see that we've just run that using the Spacey library under the hood, and we can view this, which is obviously a way better way of looking at this output than trying to look at it in a terminal or some other sort of environment. And we can do cool things where maybe we want to look at more of a compact representation. So, a few little, and the way to think about it is all these checkboxes and things, they're all just sort of values that are being passed into your functions, but this is a more ergonomic way of running those functions with an interface that you click and enter text. Okay, yep. Okay, so the way to think about Streamlit is that Streamlit apps are just Python scripts read from top to bottom. We actually kind of slightly move away from this idea of thinking about layout and callbacks. It's sort of all integrated into the one environment. So the separation of the laying out the structure of your page and Python functions. And so what you're actually doing is kind of wiring up the widgets as variables to different, your variables become slots that contain data. So what that means is it has a very sort of, it's much more, it sort of meets the mental model of a lot of people who are already familiar with writing Python scripts and not having to worry about, the styling and layout, which say with, some of the other libraries, you kind of have to think a little bit about placement and things to make it accessible. But if you just want a tool to sort of, that just works, this is a bit better go-to tool. It does have some pretty useful component API like Dash, where you can actually build your own custom components with your choice of web technology, whether that's React, Vue. And it has pretty good support for built-in widgets, but no IPy widgets at this time. Big tip here is to use the cache decorator a lot, because when you every time a request comes in on the interface, the whole script is rerun. So you actually want to make sure that you're not recomputing expensive computations many times. So I've got to the end of these libraries. I'm not going to go through this whole table because it's a very big one. But this sort of just gives you an idea of the strengths and limitations and some other properties of the library. I'll be sending out a link to these slides so you can all look at it at your leisure. But just thinking about good use cases for these libraries. Voila, I think, is great when you've got a notebook, you do things in notebooks already, and you want to be able to take the analysis, the plots that you've made, and then share them with other people. So it's probably a really good way of just very quickly prototyping an interface that someone may need to use. Or if it's something that you just use for yourself while you're doing your analysis, maybe you want to share that with someone else, over a Zoom call, chuck it through ngrok. That's the quickest way to get something probably, available to someone else on the internet. Dash shines when you want to make slightly more polished production grade dashboards. It doesn't give you sort of built-in styling, and it won't look pretty out of the box. So you do have to spend a bit of time giving it some CSS and a bit of attention in that regards. So there's a lot more flexibility, but you then have to use that flexibility to create the look of the dashboard you want. But it's also a lot more flexible for deployment options. So, anywhere you can host a Python app, you can host a Dash app, which is because it's based on Flask. Panel is sort of, I feel like the use cases are possibly a bit more niche, but if you're in that situation, I think it's going to be great for you. And especially perhaps in research where you have heavy notebook-based workflows, or that's your environment for doing work. But maybe you sometimes need to do interactive notebooks when you're doing it for yourself, but then other times you need to make notebooks to share or productionize to some extent with some degree of control over the visual layout. That it sort of ticks a bunch of different boxes. So if you're in that sort of that slice, then I think that's a great choice. And then Streamlit is really good for rapidly building out custom tools for your data workflows, whether that's annotating, whether that's sort of doing error analysis of the output of machine learning models, quickly looking at, does these sort of instances belong in the positive or the negative class, all that, and there's just a whole host of potential applications there. And it shines, I think, because it's probably the quickest to build those kinds of tools and in the most smallest amount of code. So to wrap up, web development capabilities give you or your team a data superpower. And in particular, that's around being able to prototype your data apps much more quickly and get feedback quickly. They allow you to build out bespoke tools for your project. And they also mean that the people building those tools and those apps are your team, because your team knows the data. They know the nuances. And if it's someone else building it, maybe they disappear and then you're stuck with the static sort of artifact of what they've built for you, and you can't iterate on it. So if you own and maintain the tool, you can extend it. Yeah, so I guess the idea is like we can use libraries that are designed for sort of facilitating this precise process, but without having needing you to go and learn web development, or even if you do know web development, spin up a modern web development stack. And I guess the final thing is, choose the right tool for your team or data project. There's a whole lot of options out there, and there are probably even other options that I haven't had time to mention. Perhaps not in Python. This is a great place to start. There are some other examples in this kind of space, and happy to sort of help you out if you have specific ideas or questions around that. So thank you. Oh, yes. Oh, yeah. And then when there's some useful resources here, so you can sort of use that while I'll be sharing these out. Cool. Now, I think Dave has hopefully been watching the comments. Any questions that you've noticed come up?
Yes, thanks, Ned. That was great, as always, very informative, a rich ecosystem, lots of different tools that you could choose for different scenarios. And we've got some questions from the audience. We have a question from Nigel, a question from the economist section of the audience. In simple terms, is it a front-end update by pulling or pushing data to the visualizer?
Oh, that's a really good question. That takes me to this slide. All the ones that say tornado for the server, they're capable of, well, it sort of depends, but I mean, so the one limitation of Dash is that it can't do push. It's all pull. You have to do a web request. And for developers out there, what that means is Dash doesn't support WebSockets. I believe the enterprise version might. WebSockets are sort of like long polling where you can send down streaming data. So if you want a high sort of streaming app, Dash may not be your best choice. If it's like polling every minute or so, maybe that's fine. Streamlit, on the other hand, has WebSocket support. And so if that's a priority, then maybe you want to look at Streamlit. And this may not apply to people here, but Plotly, they like to have features sponsored by companies. So if you know of anyone who would be up for sponsoring WebSocket support in Dash, please convince them to throw money at them.
Great. We've also got a question from Craig. You mentioned incorporating external content such as D3 into Dash. Is there a standard process to incorporate arbitrary external content such as other JS-based libraries, JavaScript-based libraries?
Yeah. So there's a few. Yeah. So there's a few sort of pathways. If you've got, so basically we're talking about React components. That's what you're looking at. Luckily, React is probably the most popular front-end web framework out there. If you've already know of a React component that you can port, then there's this really cool, there's a cookie cutter library where you can sort of run the command line, convert, I'm going to create a new component with this existing React app. And I've used that. In fact, it wasn't me. I gave it to someone on my team and I said, hey, I need to view tweets as like cards in this dashboard I'm making. I don't really want to create a tweet viewer component because I'm sure other people have done that. I found a React one, I gave it to him and he ran this cookie cutter tool. If you search for cookie cutter dash component, you'll find the thing on GitHub. And then it converted that into a Dash component. It actually took him an hour, which was pretty amazing. That won't always be so seamless. There may be, it has to be the right version of React and things like that. A common recipe, if you're starting from scratch, is to start with D3.js, which is obviously a highly customizable tool. Build something that's very bespoke for your needs. And then you work out, well, what are the primary parameters that go into that component? I'm going to wrap this up as a Dash component. And Plotly has guides for doing that. And then you now have this component you can use in your own projects that has sort of saved you from the, like the low level details of the D3. Your team members don't have to know about that. Only the people who built it or, someone you hired to do. So that's a really sort of powerful pattern there. But it doesn't have to be D3. It can be whatever sort of, JavaScript library you can get to play well with React.
Fantastic. And Hamid asks, would you recommend these apps for production or mostly for experiments and prototypes?
Yeah, good question. I would say of these, Dash is going to be the best bet. And because it is scalable, you can get quite a few users, like horizontally scalable on the back end. You can get quite a few users in front of it. But at a certain point, that's going to stop scaling. And the other big limitation is that every interaction, every round trip, that reactive update from the client to the server, most of the time your basic mode of doing interaction is with one of those server callbacks. And so that adds some latency. So it's harder to build out highly like real-time reactive, super low latency apps. And so if that's what you need, like, that sort of polished user experience, then you probably do need to invest in, a front-end web application with front-end engineers. It sort of depends. There are actually ways to do client-side callbacks, i.e. not do a round trip with Dash, but it's a little bit, it's not as nice an experience to write because you're writing embedded JavaScript in your Dash app. So a little bit of that is great. They have that feature, but you wouldn't want to, if you're using that all over the place, it suggests possibly, it should have been a React app to begin with.
Great. Yes. Yeah. Very. A lot more color in that answer than what's in the table here. Good to consider those other cross-functional requirements that might come up. From David, is there support for R, tidyverse, and ggplot in any of these app libraries?
Yeah. So that's and that really should belong on this. I would if you want to be able to use R, then I think you can use Voila because it is just using Jupyter. It's like you're launching a Jupyter notebook, and because Jupyter does support R, that works. Dash now has support for R, or actually has for a little while, so that works. And I think I believe why you might want to do that over using Shiny, which is obviously quite similar, is that you will get a bit more performant scalability advantages. Although I think my understanding is Shiny comes with a bit nicer styling out of the box. So, pros and cons. And not sure about panel. I suspect you may not be able to use R in that sort of a way. But I would have to double check that.
I think we've just got time for the last question from the chat, from Daniel. Would you recommend any of those for building demos for novel methods published in academic papers? It seems like Streamlit is good for that, but I wonder if you have more to say on it.
Well, it's been a while since I've been in academia. Yeah, I think it would make sense. Important concerns are reproducibility. Often the reason why people don't use these sorts of apps is because the plots need to appear in a publication, and so they actually require to use matplotlib. If you're talking about something that's like supplementary to a publication, helping with the communication, then I think, you could potentially use any of these. It's really more about, thinking about who are the users going to be, and then who are the people building the app. So, and then taking into account all the different considerations that I've been talking about. Cool. Well, thanks so much for fielding the questions, Dave. We'll might hand over, hang on. So I actually, before we hand over to you, I'm going to bring up my other notes. Right, good, okay. So I'm now going to introduce our next speaker, who we've just been hearing from. David Colls heads the ThoughtWorks Australia data practice. He is an experienced leader of strategy and delivery initiatives, an accomplished technologist, experience in research and new product prototyping, especially in mathematically and data-intensive applications. I'm really looking forward to this talk. As I said before, I've seen it before. And he's going to be talking to us about data visualization and why it's good for business.
Thank you very much, Ned. Thank you for the introduction, and hi everyone.
Dave, you might have the, there it is, good, awesome.
Great. Can you see my screen? Am I off mute?
You are great.
Excellent. You can tick those in your bingo cards. Hi and good evening, everyone. As Ned said, I'm one of the leads for the ThoughtWorks data and AI practice in Australia. And as a result, I get to work with great people like Ned on a lot of interesting problems. And tonight, I'd like to share some of the client work that we've done in the past around data visualization. And so it's structured around a number of case studies. And through these case studies, we're going to explore what problems people solve with data visualization and how they solve them. But before we get into some of the client work, let's look at how data visualization helps us respond to a health crisis. And it's not that health crisis that you might be thinking of, but we're back in Victorian London in 1854, where there's a cholera outbreak. And there's a character called John Snow, again, not that John Snow, But John Snow, who produced one of the earliest examples of data visualization, and I think this is a fascinating story, because this cholera outbreak, which resulted in over 600 deaths, happened in this region around Broad Street. And John decided to visualize the deaths by address, and he put a black bar against every street address where there had been a death. And so this was a spatial and quite a raw visualization of deaths. But with this visualization, he was able to demonstrate that there was a link to the pump on Broad Street, that deaths were clustered around this pump. And he was able to convince the authorities to remove the handle of that pump. And as a result, put an end to the cholera outbreak. And what was happening here was that the water supply from that pump was contaminated with fecal matter, which was pretty much standard practice in London at the time, to dump raw sewage into the water supply. And so obviously by removing the pump, that removed the source of the infection and brought the outbreak to a close. But what's interesting is that at the time, there wasn't any sort of theory to explain why this would be effective. At the time, it was believed that cholera was spread by miasma, or bad air. It was actually 7 years until Louis Pasteur would develop the germ theory, which could explain how this pump could be responsible for cholera. So I think this is a fascinating story for how data visualization can improve our understanding of a situation and can lead to action that improves the situation. And it's played a part in our legacy of modern plumbing to this day. And tonight we'll look at why visualization is good for business, but we're going to start by asking why it's good for people. And I think there's some key reasons why it's good for people. Certainly, ease of understanding is a key reason. There's a cognitive basis to this. Our visual system is wired to work with, to quickly understand complex data, and we can represent very complicated information very efficiently in this regard. Visualization also provides a shared view. And so when you have a shared view, all of your team or stakeholders or customers can see the same picture, and we can direct our energy towards how to improve that picture rather than trying to understand what that picture looks like or trying to reconcile differences in how we might see that picture. It does provide a holistic summary. You might say nothing gives you the big picture like a big picture. And it also provides new insight into the problem. So visualizations will show us things that we didn't set out to see when we produce them or draw them. And a great example of that is also to be seen in John Snow's visualization. There were no deaths recorded in the monastery or the brewery, as it were, because the monks in the brewery didn't drink water from the handle, didn't drink water from the tap where the handle was removed. They only drank the beer they made. So this was a new insight that came from the visualization that no one expected to see when it was created. So given that it's good for people, why do organizations that we work with visualize data? We've seen two main themes, and that's how I've organized the cases this evening, around increasing engagement, communication and brand building. And this could be to internal or external audiences, or a combination of both, or to gain insight. And so this can be operational insight, insight into data sets, insight into processes, and anywhere that we need to discover better ways of doing things, visualization can provide insight. And so how did we solve these visualization problems, or how did we approach them? In each case, we spent a bit of time to understand the problem, both from a data perspective and from a business perspective. And then we rapidly built through multiple iterations. So Ned talked about iteration in dashboarding solutions, and very important here in these custom visualizations as well. So we would build and we would iterate a custom solution. And when I say custom solution, I'm talking about solutions that were built in coding environments that are totally customizable, and as a result, we can easily tell any story and I guess their power is magnified by the open source ecosystems that they're part of. Packaged solutions have their strengths as well, but this evening I'll be focused on the custom solution approach to data visualization. And I'll talk through each of these tools with the case studies. So when we look at increasing engagement, the first case we'll look at is how to tell a complex story simply. And this is using the D3 ecosystem for building data-driven web applications. And in this case, ThoughtWorks was working with the independent market operator, who at the time were the operator of the wholesale electricity market in Western Australia. And one of their main goals is to encourage participation in the market from wholesalers and retailers. However, IMO has since been absorbed into the Australian energy market operator. And when we started working with IMO, one of their objectives was to make market activity as visible as possible to all the participants to encourage a healthy market. But they recognised that their data visualization probably needed a bit of sprucing up to meet those objectives. And so over the course of our engagement over a number of months, we built out a modern series of dashboards that showed a number of different elements of the energy marketplace in Western Australia. And so you can see there a live visualization of wind power generation with animated windmills. That was pretty cool. A range of graphs showing electricity and gas market activity. At the bottom left, at the top right, there is a view over time of market diversification. So that was one of the key objectives, to get more participants in the energy market. And so this view would show that evolving over time. And then finally, at bottom right, there's a view of the short-term energy market, which was one of the markets in place. And we'll talk through how we came to develop that visualization in this case. So the approach for each of these components, they're quite polished in their finished form there, but each of those components started with a broad question, which then led to a period of data discovery, which at the end of that was characterized by us having a clear idea of what the data was telling us, and then moving into a rapid iteration to communicate what that data was telling us in a solution. And so the hunch, or the general direction that we started with for the short-term energy market visualization was, can we show trading behavior in the short-term energy market? A number of stakeholders at IMO felt that there was some interesting behaviors going on in the short-term energy market that would be worth making visible through a visualization. And so the next stage, given that hunch or that general direction, was to start exploring the data to understand what it could tell us, and was that a compelling narrative. And the first stage of that was to get the data in whatever form was available, and with whatever tooling was suitable for the initial analysis. And in this case, it was a range of different tooling. So we can see some some extract code. We can see some analysis in Excel, and then moving into data exploration with a number of tools as well, and a number of different ways of looking at the data, trying to slice and dice it in different ways so that we could start to discover some patterns. I think that what the team discovered was that they needed to take a step back from their presuppositions of what they were going to find in the data, and produce a really raw visualization, which showed something quite interesting. It showed that one of the largest wholesalers or generators of electricity was selling electricity into the market, into the short-term energy market at high volumes in the middle of the night, while simultaneously was buying. So the producers of electricity shouldn't be buying from the short-term market, whereas one of the largest retailers was selling energy into the market at the middle of the night in high volumes. And so this was the type of behavior, and it was repeated, and this was the type of behavior that needed to be made visible to other market participants. And so now the data insight was available, and it could switch to rapidly building and refining a solution. It's a communication problem, and we switched to the delivery medium and started evolving that communication solution. And that started with a bit of a visual metaphor for what's going on in the short-term energy market. You might think of it as a series of bilateral trades with two parties, but it was actually sellers selling into a central pool of energy credits, and buyers buying out of that pool. So through sketching out a few ideas and discussing it with stakeholders and understanding what the best visual metaphor was, we were able to decide to show the short-term energy market in the center and participants around the outside. And then to work on this visual metaphor and the narrative, we could continue to iterate, explore multiple different ways of presenting this. And I quite like the one on bottom right. It's got a kind of Jetsons feel to it. But over time, continuing to test these with stakeholders and understand whether they told the story clearly, we ended up with this final form for the visualization, where it's a little less whimsical, quite clear that there's a central pool. Trades are flowing to and from participants that are arranged around the outside. And to be able to position and orient yourself in time, there's a time scrubber on the left-hand side that also shows some sort of aggregated market activity as well, so that you can play forwards and backwards through time. And so this was, this was the story of developing one of those dashboard components and how it progressed from an initial hunch through the discovery to then a data communication problem. And the result of that was, and you know, the result of the dashboard work overall was to generate engagement in the wider industry. So industry experts would refer to the IMO visualizations as the source of truth for what was happening in the energy market in Western Australia, and also that informed broader public communication as well. When there were significant energy events or supply or demand events in the energy market. It was also recognised because the visualizations were so engaging and fun to watch. You know, they had animations, they were nice and interactive. IMO developed a variation which could run on large screen TVs in their headquarters in an ambient mode. And a number of the other market participants actually took these up as well. And there were some instances where operational issues were discovered by market participants through the IMO dashboards before they discovered them through their own systems, just because people were engaged in and looking at the data, even though it was prepared on 30-minute intervals, but people were looking at it frequently and engaging with it. And as a result, it was recognised for an I Award in Western Australia. So I think it's a great example of the engagement that was built off a data visualization process. And then we've got a mini case here that I'll squeeze in that was about consuming data, but we can also make data entry engaging as well. And this case is also from Western Australia, where ThoughtWorks worked with Curtin University and their Fireballs in the Sky program to build a citizen science app that would allow citizen scientists to record sightings of meteorites that they might have seen when they were out and about at night. And so the visualization where we put in extra effort for data visualization was in the meteorite capture screens, where it was an augmented reality app that you would point your phone at the sky and trace out the trail of the meteorite in the sky. And the phone sensors would record the relevant parameters to send to the science team. But to make that engaging, there were live star maps in the background, and so that you could calibrate. And then there was a sort of WYSIWYG Fireball editor, which allowed you to drag sliders for the color, for the fragmentation, and for the speed and brightness of the fireball to sort of redesign what you'd seen in real life, because it's a beautiful phenomena if you get to witness it firsthand. What a great way to recreate it and share it with other people. And so it was a lot of fun building this scientific instrument, but the level of engagement was also really successful, because something over 14,000 sightings were submitted globally through the app. And as a result, the app was able to retrieve a meteorite the trail of which was recorded through the app. The science team were able to triangulate that from multiple readings and to be able to predict where the rock would have landed on the ground and go out and search that place and actually recover the rock. But also they were able to tell where in the solar system that rock had come from by extrapolating its trajectory backwards. And there are very few space rocks for which we know this information. So it's a tremendous scientific find enabled by some engaging data entry. So those were engagement case studies, and now I'll talk a little bit about insight case studies. And the first of these is when you need a big picture view, and in this case we're using the processing ecosystem, which is a Java-based visualization ecosystem that's often used by artists to create interactive visualizations. And this is some work with ThoughtWorks and a call center. And there's an improvement program going on at this call center, trying to balance customer satisfaction measured by NPS and the operational costs of the call center. It's a big call center that's fielding 200,000 calls a day. They're serviced by a pool of 10,000 agents who are rostered on at different times during the day, managing inquiries relating to over 500 different products and combinations of those, running 24 hours a day, 7 days a week. And so this generates about 1 gigabyte of data per week. And unfortunately, when we join this case, this is the best view we have of that data, or one of the best views we have to drive improvement on that data. There are some dashboards and some summary statistics, but if we want to start asking questions that those don't address, this is the best view we have of the data. So one of the challenges here is it was a bit smaller. Maybe we could get a clear picture, but it's so big, it's hard to get a picture of what it's like now, let alone how we might go about improving it. And so while we had some summary statistics, we wanted to get a better view of what was happening at a granular level or at a raw level to understand how we might go about improving this call center. You know, the key factors that influenced NPS or customer satisfaction turned out to be the wait time in queues. So I guess you can all imagine this with your own call center experience, and how many times customers were transferred between different agents to have their inquiry resolved. And so again, we went through a process of picking a visual metaphor and then rapidly evolving it. What we started with was the idea that transfers could be represented as chords across a circle between queue types, and we could show, or between inquiry types, and we could show the length of queues around the outside of the circle. So that's that thing at the top left that I'm just realizing now looks a little bit like a coronavirus as well. But we rapidly evolved that through a number of different visualizations, number of different formats. I'd called it an amoeba and a disco at one point as well, because we started adding some animation, because we realized that how this changed over time was an important thing to be able to see as well. And as we were doing this, someone said, "Hey, that's just like the Matrix." And at this point, it was patently untrue, but it was such a good idea that we decided to actually make the visual metaphor for the visualization the Matrix metaphor. And this made a lot of sense, because we could describe it as looking for glitches in the call center, much the same way that there are glitches in the Matrix. And so that's Matrix version 0.1 on the right. But where it ended up, it was a little bit more polished, and this is what it looks like. And you know, if you're seeing this for the first time, you might not think of this as a call center, but I'll talk you through what's happening here. So every character on the screen, the katakana characters, every one of those is a call that the call center is managing at this time. If that call is waiting in a queue, then it's in the orange part of the screen up at the top. And the longer it's been in the queue, the further down the orange part of the screen at the top it moves. If it's been answered and a customer's talking to an agent, then it's in the green part of the screen down at the bottom. And the further down the green part, the longer the call has been active. This view shows calls that have been in a queue or on hold for an hour at the bottom of the orange section, and they've been talking to agents for 2 hours at the bottom of the green section, to give you a sense of scale. And then the horizontal position is based on the type of inquiry or the product that the customer is calling about. And so those are just assigned across the screen. And you can also see some bubbles, which are customers hanging up in frustration as they spend too long in the queue. And I did say that we wanted to see what this looked like as it was animated as well over time. And so this is, that wasn't just a static view, but we had a kind of a hyper time visualization of what was happening in the call center. So on here, we can overlay the types of things we expected to see. We expected to see customers calling and inquiring about things like their bills, for instance, and they'd be sitting in a queue, and then those calls would be answered by agents. We expected to see the calls dropping into the active call area where they were talking to agents. These would be about different types of inquiries. So we had inquire bill, and there's a fault, and then here's a move fixed inquiry. And we also expected to see transfers. So those are the lightning bolts shooting from queue to queue. But the things that we didn't expect to see when we drew this, the insights that we got from it were, for iPhones, there were no inquiries. There were no customers inquiring about iPhones. We weren't so surprised no one was inquiring about Blackberries. What we were surprised about was that business inquiries were coming in, but there were no agents available. There's another point, which is that the queues weren't actually FIFO queues, but I'll explain that later. And we could see that calls were getting stuck in a loop. Request help here, getting put back into the request help queue. And so all of these things contributing to a poor customer experience that wouldn't have necessarily come out through the existing visualizations. The FIFO queue one is interesting. You can see calls are dropping down as we slow down to real time here. You can see calls are dropping down without the most mature or aged call in the queue dropping down first. So the data is showing us that the queues aren't actually acting as FIFO queues, although when we look at the summary statistics, things look right. So this was a great source of insight, and it was only when someone asked, why isn't that one dropping down? That oldest call in the queue should be dropping down first. That we were able to recognise that there was actually a significant issue in how the data was prepared for analysis. So the lesson from this one was that a raw and fuzzy visualization can help you discover questions. So that was an example of a question. Why isn't that call being answered first? And then that could prompt a round of investigation to quantify how we might answer that question, and then a further round of inquiry to actually answer that question and decide how to address it. And a visualization like this can also help you get attention. Some people have asked me, was it a little bit frivolous? How did you engage stakeholders with something that seemed a bit frivolous? And my answer has been that although it's unorthodox, it was able to produce results, and we could demonstrate that we were getting results, and so that it was an effective use of time. And it was a very minimal investment as well. So another small case before we end. When it comes to gaining insight, this is a little bit tongue-in-cheek, but we often discuss questions where we're asked, can machine learning solve this? Can it provide insight? Can we outsource the need for understanding data and working to a solution to a machine? And yes, machine learning is extremely powerful, and it should absolutely be used, but it should be used in combination with data visualization. And this isn't actually our client work, but this is what I get up to in my spare time when I am trying to find things to entertain myself in Melbourne in our stage 4 lockdowns. And this is a project to improve my wheelies on my bike, and I'm collecting a lot of data from my phone as I do this, and collecting that data to give me some insight into how to improve. And so one of the questions I wanted to ask was how to characterize a wheelie, which the data that comes off my phone is a time series trace. and we're looking at about 10 seconds there at a resolution of 1/10 of a second. So about 100 data points describe a wheelie, and 100 data points is too many for me to fit in my head. So I'd like to be able to describe a wheelie with just 3 numbers. And definitely one of those numbers is going to be duration, because that's actually how I'm measuring my improvement. But then what else would I add? I'd probably describe something about the amplitude, like how high off the ground did that trace go? And probably also something about the wiggliness, how smooth was it? Or how out of balance was it over time? And, you know, if I had those numbers, could I then draw what the wheelie would look like? Because that would show me that it's those numbers captured the essence of the wheelie really well, and I could describe it to somebody else and talk about how I was going and get their feedback. So you know, that's how I might go about describing it. But I thought, let's ask a machine how it would describe those wheelies. And so in this case, I've used a technique called an autoencoder as a neural network. And what that does is it takes those 100 data points every 1/10 of a second over 10 seconds for all of the wheelies that I've recorded, which is over 2,000 now. And
Oh no, Dave, we can't seem to hear you. Is everyone else? Yeah, I think we've lost. Wait, are you back? Are you back, Dave?
Sorry?
Oh, do you want to just, I think we lost the last bit of your last slide. I think maybe your connection dropped out for a bit. If you just back up to, you just started describing putting the features through the autoencoder.
Yeah, thanks, Ned. Sorry for the interruption, everyone. Yeah, as I was saying, the so the raw wheelie trace is 100 data points. The autoencoder learns how to represent that in just 3 numbers, and then reconstruct that trace. And the autoencoder is trained by how well it reconstructs the case. And so down at the bottom, there are some reconstructed traces overlaid on the original traces. And through that process, we're hoping to discover the 3 numbers that a machine chooses to describe a wheelie. But as it turns out, those 3 numbers don't have as simple as an interpretation as the 3 numbers that I thought I would use to describe a wheelie. And so you can see here in this chart, down the middle, in the middle column, there is that recreation of a single. So I've chosen a single wheelie and overlaid the reproduction on it. And then in each row, I've varied number 1, number 2, or number 3, the dimensions or latent dimensions of the autoencoder, to see how the description of the wheelie changes as a result of that. And so the machine has decided that wheelies can either be long and wiggly or short and smooth. That's what happens when we change the first number. Or they can have, and this is my interpretation, you might see different patterns in this as well, or they can have a gradual landing or a sharp landing if you vary the second number, or maybe they're really short and low in profile, or long and high in profile. So it seems like there's things that I wouldn't have immediately thought of in there, and there's also things that I thought of, but they're combined in interesting ways. But I still want, but given duration is really important to me, I want to understand, how does the machine think about duration? And this is where another round of data visualization comes in. And what I found was that after playing around with visualization, was that the duration was there, but it was actually wrapped up in the space in a complex shape that was nonetheless very clear. If you look at this point cloud and go from purple through green to yellow, then those are getting longer in duration. And so it's pretty clear when you look at it visually how duration is captured by the machine, even though it's not one of those 3 dimensions. And so then that allows us to do fun stuff like smoothly recreate imaginary wheelies of arbitrary duration as we move through that space. This is combining a good example of how we
no, we seem to have lost Dave again. Hopefully he reappears shortly.
Learning, we can use that to find some insight, but then data visualization will help us to interpret that. With visualization, we can then specify problems and how to validate solutions, and then supervised machine learning can solve those problems. So for instance, the fact that I found that some wheelies, the machine thinks some wheelies have a gradual ending and some have a sharp ending, gives me some ideas about how I could turn this into a supervised machine learning program to predict when my wheelie is going to come to an end and what kinds of things I could avoid to keep that wheelie going for longer. I'm conscious of time and I'll quickly go through the takeaways. So I think the benefits of visualization that I'd summarize from these cases are that we can tell complex stories simply, that interacting with data becomes exciting, that fuzzy visualization can help you discover questions, which can then lead to improvements, and that data visualization and machine learning can be really complementary when it comes to finding insights. So when would you consider using an approach like I've described in here? I'd say based on those objectives of engagement and insight, where we have a complex story to tell, but we have some data to tell it with, or where there's no shared big picture. I see my internet connection is unstable again. How much did you miss? Or where there's no shared big picture, but the data is there. And when it comes to execution, it's easy to start small and stay lightweight. We can use real data and lots of it, and iterate. Where you start will not be where you finish. And only by seeing what the data shows you can you determine a direction to take it in. And that by building with a custom solution gives you the flexibility to do this. And if you're interested in getting started in any of these open data visualization ecosystems, then just to summarize what we've looked at, the cases here tonight, D3 and the JavaScript ecosystem for building interactive web visualizations, the processing, which is based on Java, but a simplified language and customized to data visualization. It's often used by artists and to produce interactive installations, and has a lot of interesting hardware extensions and integrations as well. And then Matplotlib and the broader Python data science and machine learning ecosystem, which of course Ned did much better justice to than I did in this little custom visualization case study. So there's that's a really rich place to focus if you want to get started in an open custom visualization ecosystem. So I might leave it there, and thank you for your time.
Cool. Thanks so much for that, Dave. Yeah, you dropped out a little bit, but it wasn't too bad. I think I think it didn't interrupt the flow too much. Yeah, no, thank you so much for that little walkthrough of, a bit more custom solutions that possibly fall, I guess outside what we might prototypically think of as, your sort of more standard visualizations, and really demonstrated, the power of when you have a particular problem that you want to sort of get some specific insights or, generate engagement with. So we got a couple of questions here. So firstly from Danielle, when do you decide in which kind of chart you should use in order to deliver your message to the stakeholders as best you can? So I guess deciding on which, because there's obviously so many charts to choose from, at which point in the process do you sort of choose?
Yeah, it's a really good question, and it's I think I'd come back to the message around iteration. Try a few different ways of presenting the data, and through that you'll understand how it looks in different formats, and you will probably end up somewhere different than where you started. There are, however, some useful flowcharts out there where people categorize the different types of data visualizations available from and what their strengths and weaknesses are for showing. So yeah, choosing between, say, a scatter plot and a bar chart. We had an internal conversation recently about the best way to show distributions as histograms or density functions or even ridge plots or violin plots. So the reality is that there are lots of different ways of showing it, and I would recommend iterating through a number of different options to understand how it looks best, and maybe even using multiple visualizations as well.
Cool. Another question is, do you have any experience so this is from Craig, do you have any experience regarding digital versus printable visualizations based on client acceptance?
Yeah, good question. Processing is actually interesting. It's got different rendering modes, so you can render to a bitmap or you can render to PDF compatible vector, which can be great for producing really big, like A2, A1, A0 type visualizations that capture a lot of data, and those can then be printable. So I think when you produce a hard copy visualization, it can be great to get people around it and to interact with it. And I think a lot of these visualizations, we want to make people, we want to encourage people to be able to change them and question them and point to things on them and annotate them. So I think in that case, that like a hard copy or printable visualization could be really effective as well. Obviously, Matplotlib is designed for hard copy format as well. In D3, it's manipulating DOM elements, and so it will you'll be able to print as in standard behavior, but often things will look a bit different when they're printed from a web page. Those are some technical considerations, but I'd say it's definitely possible to do. And if adopting processing for your custom visualization environment is not a big hurdle, then that would probably be the easiest medium to work in for something really custom and printable.
Great, thanks. Okay, and I think we're just going to squeeze in one last question from Errol, which I'm going to sort of summarize. Given you've demonstrated a lot of value that's come out of these projects, what would you recommend in terms of developing specific skills and tool sets for people who want to sort of get into this space and help out, clients or organizations? How would people get hired to do this stuff?
Oh yeah, great question. I think there's a lot of benefit in just finding a data set that's interesting to you, and then getting started with the tooling. So having a project is a really great way to guide your learning, and it will bring up problems that you wouldn't encounter through the regular process of tutorials. But tutorials will be there to guide you to solving those problems. So I recommend it if this is an area that interests you. The great thing about these open ecosystems is that you can get started on them right away once you've downloaded and installed dependencies. And there are big communities online that will provide guidance. But the key thing to direct your learning is to have a project that interests you around a data set that you want to tell stories with.
Yeah, I'll echo exactly what you just said. Find yourself a project. And I think a key thing there is that it'll get you more motivated. Because if you're just sort of going through tutorials, it sort of can be hard to sort of, kind of come back to the cold face of your, education. But if you've got something you're passionate about, it'll make you come back for more. And the other thing I'd say is that there's plenty of different resources for picking up visualization online. Once you start playing around with some tools, like as a first step, then when you can sort of get a taste for what you can do and you want to take it further, then have a look at some books and courses. And I think a really popular thing in the data viz community is sort of sharing, learning by sharing and commenting on what you have done and what other people have done. And in that tradition, there's a sort of an activity called Makeover Monday, where everyone is given a data set or that's right, it's an existing visualization. It's like, how could we make this better? How could we make it over? And so there's a whole catalog of, the before and after. And so there's lots of examples where you can see how have people improved, or, plenty of sort of, lots of resources to learn from. So let's, with that, thank you once again so much for that, Dave. And we'll just sort of, are about at the tail end of the proceedings.